morning everyone. My name is Julian. I represent Group 4 and our topic is machine learning. Artificial intelligence, machine learning and deep learning are often used interchangeably. They are not exactly the same thing. Artificial intelligence is the broader concept of machines that are able to carry out tasks that we consider smart. Deep learning is a subset of machine learning and machine learning is a subset of artificial intelligence. Machine learning is an application of artificial intelligence that provides the system to learn automatically and improve from experience without being explicitly programmed. It focuses on developing programs that can access data and use it to learn for themselves. The primary aim is to allow the computer to learn automatically without human intervention. Machine learning is dynamic, that is, it can modify itself when it is exposed to more data. Therefore, it is less brittle and less reliant on human experts. In 1959, Arthur Samuel, one of the pioneers of machine learning, defined machine learning as a field of study that gives computers the ability to learn without being explicitly programmed. Machine learning programs are not entered into a computer, but they adjust themselves in response to the data they are exposed to. Arthur Samuel designed a computer program that could play checkers. His goal was to teach it to play checkers better than himself. This is not something that can be programmed, but rather something that can be learned with experience when it is exposed to such situations. So he succeeded, and in 1962, the program beat the checkers champion of the state of Connecticut.
That's Paul. He loves listening to new songs. He either likes them or dislikes them. Paul decides this on the basis of the song's tempo, genre, intensity, and gender of the voice. Now for simplicity, let's use tempo and intensity. So here, tempo is on the x-axis ranging from relaxed to fast, whereas intensity is on the y-axis ranging from light to soaring. We see Paul likes the song with fast tempo and soaring intensity, while he dislikes the song with relaxed tempo and light intensity. So now we know Paul's choices. Let's see. Paul listens to a new song. Let's name this song as Song A. Now Song A has a fast tempo and soaring intensity. It lies somewhere over here. So now can you guess whether Paul would like the song or not? Correct. He likes the song. By looking at his past choices, we were able to classify the unknown song very easily. Now, Paul would listen to a new song. Let's name this song as Song B. Now, Song B lies somewhere over here, with medium tempo and medium intensity. Now, can you guess whether he would like the song or not? Here, the choices are very unclear. It is neither relaxed or fast, neither light nor soaring. Now, this is where machine learning comes in. Let's see. Now, if you draw a circle around song B, there are 4 votes for like and 1 vote for dislike. So therefore, Paul will definitely like the song. Now this was a basic machine learning algorithm. It's called K-nearest neighbors. So this was just a small example from one of the many machine learning algorithms.
Discussing about supervised learning. So supervised learning as the name indicates the presence of a supervisor as a teacher. The supervised learning consists of set of input and output. That is, it's an algorithm to map the input function to output. We know the target output with the correct value, and we are given a set of input to the machine for training, and the machine produces the exact output corresponding to the input set. Let's take a real life example. The learning process of a child. The child doesn't know how to read and write. He or she were taught by the parents at home and teachers at school. The child are trained and molded to recognize the alphabet and numericals. Let's consider one example. Face recognition technology. in the case of machine. In face recognition technology, we are provide a set of image as input to train particular machine for the identification of particular person. The next time that person provide a new set of images to a machine, the machine identifies that person and produce a true values output. Learning are classified into two types. First one, classification. Second, regression. First one, classification. Classification problem is when the output variable is a category such as red or blue, diseases or not diseases. Regression problem is when the output variable is a real value such as humidity pressure.
Next is the unsupervised learning. So now in unsupervised learning, the data is unlabeled. So the algorithm tries to find the commonalities between the input data. Now, as unlabeled data is more abundant than the labeled data, the machine learning methods that facilitate unsupervised learning is very valuable. Now, the basic common goal of the unsupervised learning is to discover the hidden patterns within a data set. And unsupervised learning is commonly used for transactional data and anomaly detection. For example, you may have a large data set of customers and purchasers. Now, as a human being, we find it difficult to find the similar attributes from their customer profiles. Now, if we feed this data into our algorithm, we can see that women of a certain age group who buy unscented soaps are likely to be pregnant. So marketing campaign related to baby products and pregnancy products can be targeted to this group of women. Now, another example of unsupervised learning is untagged photos of dogs can be used as input data for the algorithm to find the likeliness and classify the dog photos together. Now next we'll be talking about reinforcement. Now reinforcement is all about making decisions sequentially. In other words, we can say that the output can be decided from the current input state and the next input can be decided from the output of the previous input. Now, in reinforcement, the reinforcement agent decides on how to perform the given task. And in the absence of the trainee data set, it tends to learn from its previous experiences. Now let us take an example. Now in this example we have an agent and a reward and there are many hurdles in between. Now the aim of the agent is to get the reward in the best possible path. Now in the given image there is a robot, a diamond and a fire. Now the goal of the robot is to get the reward, that is the diamond, and to avoid the hurdles, that is the fire. Now the robot learns by trying all possible paths and choosing the path with the least hurdles. Now each right step is rewarded and each wrong step will subtract the reward and the total is calculated.
Machine learning algorithms can be broadly categorized into three different categories, namely supervised learning, unsupervised learning, and reinforcement learning. Each of these categories are classified into different algorithms. Let us discuss some of them. Naive Bayes classifier algorithm. What would happen if you had to classify data text as web page, a document, or an email manually? It is a very time-consuming process. This task can be performed by using the naive Bayes classifier algorithm. This algorithm is based on the Bayes theorem of probability and it allocates the element value to a population from one of the categories that are available. An example of this algorithm is the email spam filtering. Gmail uses this algorithm to classify an email as spam or ham. Spam is the junk mail, whereas ham is the good mail or the mail which is not spam. K-means clustering algorithm. Let's imagine that you want to search the term date on Wikipedia. Now date can refer to a fruit or a particular day. So Wikipedia groups the web pages that talk about the same ideas using K-means clustering algorithm. K-means clustering algorithm, in general, uses K number of clusters to operate on a given data set. In this manner, the output contains K clusters with the input data partitioned among the clusters. Linear regression algorithm. The linear regression algorithm shows the relationship between an independent and a dependent variable. It demonstrates the impact on the dependent variable when the independent variable is changed in any way. So the independent variable is called the explanatory variable and the dependent variable is called the factor of interest. This example shows the average height of children in a particular age group. Logistic regression algorithm. The logistic regression algorithm deals in discrete values, whereas the linear regression algorithm handles predictions in continuous values. So logistic regression is suited for binary classification, wherein if an event occurs, it is classified as 1, and if not, it is classified as 0. Hence, the probability of a particular event occurrence is predicted based on the given predictor variables. An example of the logistic regression algorithm usage is in politics to predict if a particular candidate will win or lose a political election. Decision trees algorithm. Suppose that you want to decide the venue for your birthday. There are many questions that factor in your decision, such as, is the restaurant good? Does the restaurant have live music? Is the restaurant close by your house? Etc. Each of these questions has a yes or no answer that contributes to your decision. This is what basically happens in the decision tree algorithm. Here, all possible outcomes of a decision are shown using a tree branching methodology. The internal nodes are tests on various attributes. The branches of the tree are the outcomes of the tests, and the leaf nodes are the decision made after computing all of the attributes. In the above illustration, the decision tree classifies a guest as either vegetarian or non-vegetarian. Each node represents a predictor variable that will help to conclude whether or not a guest is non-vegetarian. As you traverse down the tree, you must make decisions at each node until you reach a dead end.
Anna, play my dance mix.
I booked your workout for 6 p.m. tonight. Can I get you a ride?
Hey Cortana, what's next?
Hola, konnichiwa.
Bonjour.
Hello? Imagine if you could understand and communicate with people across 100 languages. With the Google Translate app, now you can. Translate lets you connect with the world around you, no matter where in the world you are. It's free, and it's always with you right on your phone. Let's try it out. Tap the microphone to use your very own voice.
Is there a pharmacy nearby?
Hay una farmacia cercana.
You can even have a complete conversation with someone who speaks a completely different language. Just select your language and their language and start talking.
I'm late.
मुझे देर हो गई.
मुझे एक शॉर्टकट पता है.
I know a shortcut.
Your speech will be translated loud and clear, and you'll be able to see it too. Now let's say you're looking at a menu in a language you can't read. Using your camera, you can translate the words instantly. It could save you from ordering something that sets your mouth on fire. And it even works offline. Speaking of offline, so what if you don't have data? Or you're in a place with no Wi-Fi? Don't worry, you've got this. You don't need internet to use Translate. Just download the offline translation file for the languages you need. Translate works without data, in a jungle, on an airplane, or in deep space.
At the Google Arts and Culture Lab, we asked ourselves a simple question. What if we could explore centuries worth of art, history and heritage using the latest technology? And that's what we've been experimenting with at the lab.
Machine learning is so exciting. I mean, there is so many things you can do when a computer, when a software starts understanding what is inside the content.
Art Selfie allow you to connect with artworks in a very personal way. You just take a selfie. Machine learning algorithms try to look within tens of thousands of artworks to see if there is one that looks just like you. The worldwide response was phenomenal as people are starting to share their matches and talk about them. Tens of millions of selfies were taken and matched to artworks.
Life magazine is one of the most iconic publications in history. Life Tags is an experiment that organises Life magazine's archives into an interactive encyclopedia.
Art Palette is an experiment to play with colors. So everyone can create a palette of color and get in return artworks that match this palette. We hope Art Palette can be great inspiration for designers, for artists, because it's able to relate palette of colors with artworks.
Our goal is to open new pathways to explore within arts and culture and see how modern technology can be applied to further empower artists, institutions, and audiences.
In capital markets, insurance, retail and banking, artificial intelligence is a smart way for the biggest players to act with the agility of fintech competitors. Financial services are quickly adopting artificial intelligence, machine learning and deep learning, understanding their potential to strengthen cybersecurity, accurately qualify credit risk, track and optimize customer interactions, automate processes, and identify and stop fraud in its tracks. Automation, cloud technology and streamlined IT are more important than ever before. For example, machine learning detects fraud with up to 85% accuracy, increasing to over 90% with deep learning algorithms. This matters when over 46% of Americans have had their credit card information compromised, and credit card fraud cost over $27 billion in 2017. But with advances in deep learning, driven by NVIDIA's powerful GPU accelerators, the finance industry is heading towards even more sophisticated risk analysis, portfolio management, and forecasting. By embedding and managing AI in your infrastructure, HPE and NVIDIA are making AI work for your business, for IT, and for your future. For data scientists, leaders in fraud, compliance and trading, and those leading R&D, HPE Point Next supports digital evolution within finance, moving you ahead to master the full potential. With machine learning, manufacturers are already exploring and simulating designs in virtual environments, intelligently managing logistics, and printing 3D prototypes. They are optimizing costs at each step by speeding up design and testing, and keeping machinery running to minimize downtime. Soon, advances in deep learning, driven by NVIDIA's powerful GPU accelerators, will make virtual product development even more accurate by simulating models with unprecedented accuracy. Environments like NVIDIA's Holodeck make sophisticated digital twinning a reality for manufacturers, minimizing expensive design iterations. At production stage, robotic machinery will contribute to cost savings by identifying downtime opportunities and shutting itself down. And service operations are revolutionized by predictive maintenance that optimizes equipment's operational lifetime and stops failures before they even occur.